Hello everyone. Today I'll start with exercise 1D of class 9 number system. Meghalaya board exercise 1D. In the last video I have explained about irrational numbers. Now the question will be based on irrational numbers. So let's see what is the first question. First question is, define an irrational number. How does it differ from rational number? We have to define irrational number. Number 1, define irrational number. So what is irrational number? Irrational number is what? Any number of the form, any number which is not of the form, which is not of the form. Because any number of the form a by b or p by q is rational. Irrational is any number which is not of the form p by q, where p and q are integers and q is not equal to 0. So this is an irrational number. So you can just write down example. Example is root 2, root 3, root 8, etc. So many. These are irrational numbers. Now the question is, what is the difference? What is the difference? Question is what? How does it differ from rational number? How does it differ from rational number? So let me talk about in terms of decimal expansion. Okay? Rational number has terminating or non-terminating, repeating, non-terminating but repeating decimal expansion, whereas irrational number has non-terminating, non-repeating decimal expansion. I have already given you in the introduction video of irrational number. The difference also you can see there, but I am writing here again. So you can just pause the video. Rational number has terminating or non-terminating repeating decimal expansion, whereas irrational number has non-terminating, non-repeating decimal expansion. We have already seen all these things. So you can pause the video to note it down. I'll go to question number 2. What is question number 2? Question number 2, examine whether the following numbers are rational or irrational. I have to examine whether the following numbers are rational or irrational. Okay, number 2, sub number A1 is root 5. Root 5 is directly irrational. Examine. So it's not that we have to prove it, just examine it. See, by looking we can know that okay, root 5 cannot come out of the root, so it becomes irrational. Okay, I'm writing in short form, you can write irrational. Now sub number 2 is root 9. Root 9 equals to root 3 square, and 3, if it has a pair, it comes out of the root, equals to 3. Then that becomes what? Rational. Rational means Q. Okay. Now next is sub number 3. It is root 45. Root 45 is 45. What can I write? 45 is 315 times. and 3 5 times. And 3 square into 5 I can write. 3 square into 5. 3 can come out of the root, but root 5 remains as it is. So that is irrational. I told you, rational multiplied with irrational, the total is irrational only. Multiplication, addition, same cases. Sub number B1. B1 is what? Not B1, is sub number 4 only. So this is sub number 3, this is sub number 4. Sub number 4 is 5 minus root 2 and then 5 plus root 2. We have to tell whether it is rational or irrational. Don't simply declare. Last time I told you, rational added with irrational or rational subtracted with irrational, the output is called irrational. But here it is in product form. I have to simplify first. Things are not clear here. So, solution, what can I write here? See this one, it is a plus b, a minus b form. Last time in last introduction video I give you the identities. A minus b or a plus b into a minus b is equal to a square minus b square. A minus b, a plus b is a square minus b square. Identities of algebra. Okay. Now you see a minus b, a plus b. See the 5 5 same. Root 2 same, the difference is one is plus and one is minus, and there's a product here. A minus b, a plus b is a square minus b square. See, 5 square minus root 2 square. Our a is 5, b is root 2. So ultimately this is equal to 25, and this is square and square root can be cancelled, is equal to 2. So this becomes 23. Square root into square root. See, square root into square root is 2 only. Don't write that is 4. Square root into square root into square root is 2. Square root of 2 into square root of 2 is 2. Like square root of 5 into square root of 5 is equal to 5. Because what do we have? It becomes, see, the root are same, I can multiply. 5 into 5 is 20. I can write 5 square. So 5 square means it is 5. So that's how it becomes 5. Okay. So this is rational or irrational? It is rational only. Q, all right, in short form. Q, rational. So you can just pause the video to note it down. So I just use identities, or else you can product with 5 with 5, 5 with root 2, minus with plus, root 2 with 5, minus with plus, root 2 with root 2. Either also you can do, or directly I can apply the identities here. Now I'll go to sub number 5. Sub number 5 is nothing but root 2 plus root 3 plus root 2 whole square. So I have to declare, I have to tell that whether this is rational or irrational. So things are not clear. See, there is a square. So let me first simplify this one. This is a plus b whole square. So last time I already give you identities. A plus b whole square is a square plus 2ab plus b square. So remember the identities, a square plus 2ab plus b square. So a plus b whole square. So a square is root 3 square plus 2ab. 2 is 2. A is root 3 and b is root 2 plus b square. B square means root 2 square. Check. A square plus twice ab plus b square. Square and square root cancel. It becomes 3 plus 2 root 6. Okay. See, root are same. 3 2s are 6. I can multiply, but same case cannot be done with addition or subtraction. You cannot write root 3 plus root 2 equals to root 5. You cannot write that. This is wrong. Or subtraction also cannot be written. But multiplication, if the, see, the square root, this is also square root. So if there is a multiplication, you can multiply. 2 3s are, or 3 2s are 6. Okay. Plus root 2 square is 2. So I told you square and square root can be cancelled. Now you remember very important step here. You cannot add or subtract with this one. You cannot add. 3 plus 2 you cannot do because 2 is multiplied. Because this is what? This is irrational as a whole. Okay. Purely rational and purely rational can be combined. Now this one. 3 plus 2. 3 plus this 2 is nothing but 5. Plus 2 root 6. This is left as it is. Now Now I cannot add or subtract with this one. So this becomes what? Irrational. Q naught. Q on the top bar. Irrational. Okay? Because this is rational. Added with this as a whole is irrational. So ultimately everything is irrational. So this is also done. 6. 6 is root 6. Root 6 minus 2. Root 6 minus 2. So directly this is what? Irrational. Why? Because root 6. 6 cannot come out of the root. So this is irrational. Subtract with rational. So as a whole, it is irrational. So this is done. Pause the video to note it down. If you have any doubts, please comment me. Okay. Next, B. Sub number 1. Sub number 1 is root over 9 by 27. See, root goes to denominator also, 27. So let's see that whenever you have square root, numerator and denominator, it goes to both. Root over 9 by root over 27. Root over 9 means root over 3 square. I am writing every step. And 27 means what? 27 is 3, 9 and then 3, 3. So 3 square into 3. 3 square into 3. Now square and square root get cancelled, it becomes 3. But you cannot cancel this one because there is another 3. Square root is also for this 3, not only for this one. So square root goes to both like this. Okay, we'll be doing in another exercise in detail everything this type. 3 by this one cancel, 3 into this is root 3. So root 3 cancel, 1 by root 3. So this is irrational. Right? Rational divided by irrational is irrational. I already gave you in the introduction video. Please watch that first and then you can come to this exercise. Things will be very easy for you. So this is done. You can pause the video to note it down. Sub number 2. Sub number 2 is minus root over 81. See? Minus is minus, we don't have to do anything here. But 81 is 9 square, isn't it? 81 is 9 square, 9 nines are 81. Now, square and square root can be cancelled, is minus 9. Minus 9 means it is rational. Can come out of the root, rational. So you try with square root of 2 to 5. Try with this one, whether it is rational or irrational, you tell me. Now I'll go to number C. C sub number 1. C sub number 1 is 2.13, 133 and 1333 and dot. Okay, last time I already in the introduction video, this type of examples I already showed you. Now you check. See, this is in terms of decimal expansion they gave you. Now you recollect it. What is rational number? Rational number has what? Rational number has terminating decimal expansion or non-terminating repeating decimal expansion. Is it terminating? Doesn't stop. Okay. Is it repeating? Just check after point 13, 133, 1333. This is not repeating. I cannot call this one as repeating. Though 13, here also 13, but here again, see, these things are not repeating. So what can I say? This one is what? Irrational, because it has non-terminating, non-repeating decimal expansion. It is irrational. So sub number 2 is nothing but 4.2576. 4.2576. It is clearly what? Rational. Clearly stops, no? Stops. See? Terminates. Terminating decimal expansion. So, it is rational. So, by looking, this is in terms of what? Decimal expansion they give you. Number 3. Okay? Number 3 and number 4. These are two questions I'll write here. You try it by yourself. 5.04, 004, and 0004, dot. Okay, let me know whether it is rational or irrational. Okay, you comment me. Sub number 4 Sub number 4 is 2.346 46 like this. Now this also you comment me in the comment box whether it is rational or irrational. With the reason, I want with the reason. Okay, these are the two questions which you can see. Now number 3, I'll go to question number 3. Question number 3 is, in the following equation, which variables represent irrational numbers? In the following equations, which variable represent irrational numbers? Okay, which one is irrational numbers? So let's see which one is rational, which one is irrational. Okay, I have to tell, the question is same. Okay, whether I have to say that it is rational or irrational. That's the question. Sub number 1, let's see. Sub number 1. Sub number 1 is x square is equal to 3. Now solution, how will you solve? I'll just tell you how will you solve. X equal to square root of 3. How come square root of 3? Always remember, when square goes to the other side of equal to sign, it will become root over square root. If cube goes to the other side, it will become cube root. Like that. Now square goes to the other side, whatever is here, it may be so long, all will come under the root. So here, it becomes root over 3. Now what is this? Rational or irrational? It is irrational. Because root 3 is irrational. So this is irrational. Now, very easy way you can do it. Sub number 2. Sub number 2 is y square equals to 16. Okay. So one point I just missed in the sub number 1. Just I explain you here again. It will go for square root of 16. Now whenever square goes to the other side, it becomes plus minus. It is plus minus. Why? I'll tell you. Because if I say x square is equal to 9, no, x square is equal to 9. Have a look. X equals to, I say square root of 9. Square root of 9 is 3. X is 3. Now you check that 3 square gives us 9. But minus 3 square also gives us 9 only, no? Because negative square is positive and 3 square is 9. Negative square, minus into minus is plus. Negative to the power even number is always positive. Negative square, positive, 3 square. Now you check, 3 square is also giving you 9. Minus 3 square also giving you 9. So that means what? You always have to insert. You always have to insert here. You always have to insert here plus minus, plus minus. Okay? So in the last sum also you insert plus minus. Now let me see. Plus minus square root of 16, I think you know it is 4. Because 4 square gives us 16. So this is rational, purely rational. Because it comes out of the root. It's rational. Okay. This is sub number 2. Pause the video to note it down. You can write it is rational. Next is z square, sub number 3. Z square is equal to 0.09. So in this type, what to do? Okay. Now let me first remove this point. So it is 9 by 100. Hope you know how to remove it. Just write down the number and divide it by 1 means point. The remaining convert it to 0. Now there is no decimal. Z equals to square root of 9 by 100. That is also plus minus. Now you check, it is plus minus. Now directly I'll write square root of 9 is 3 divided by square root of 100 is 10. Because 10 square gives us 100. Comes out of the root, no? So this becomes rational. Very simple. I just remove from the point. From the decimal I convert it into fraction. It's 9 out of 100. Point means 1. The remaining 0. And you shift the square to the other side, becomes root over. There also plus minus. I tell you why plus minus. And then root over 9 is 3. And root, because root goes to numerator and denominator, I told you both. It goes to both numerator and denominator. Multiplication also, it will go to each and every multiplicand. Okay. Now I'll go to next sum. Sub number 4. Okay, this you give me the answer by yourself in the comment box. 15 by 4. Sub number 5. Also you try. V square equals to 3. Sub number 6. Also you try. It is W square is equal to 6.9. This one also you try. These 3 sums you try and comment me in the comment box. Now, so you can just note it down, these questions which you have to do by yourself. Last problem left. Now the last problem is prove that. So I'll write a full question here. Prove that root 3 plus root 5 is irrational. I have to prove that this is an irrational number. Okay. Now by looking to we know because root 3 plus root 5, it is irrational only because root 3 is irrational. Added with irrational, definitely it is irrational. In any terms, if there is any irrational there, the total is called irrational only. And now I have to prove it. How do I prove it? So I'll give you steps here. Okay, how to prove this is irrational. So again, contradiction method I'll use. Okay, what will I do? I'll assume. Okay, let me assume that. Okay, this is rational. Okay, let x equals. So let me just assume it is x. Just check my introduction video. How did I do it? But little differently I will do. Let x equals to root 3 plus root 5. Let this be a rational number. Be a rational number. Now assume this to be a rational number. Now what will I do now? I will square both sides. I'll square both sides. Now squaring both sides. Squaring both sides. What does it become? X square equals to root 3 plus root 5 whole square. It's not an individual square. It will be whole square. That's called squaring both sides. Now I square both sides. This side as it is. But this side you check. It is a plus b whole square. Is a square identities I am using. A square plus 2ab, 2 root 3 into root 5 plus b square plus root 5 square. I repeat, a square plus twice ab plus b square. When you square both sides, it goes everything. Like if there are 4, 5, 6 terms also, it will be the whole square. So x square, this one as it is, a square plus 2ab, remember a is root 3, b is root 5, plus b square. Now remember that, I am going to rub this part, remember that I assume that x to be a rational number. Okay, but I have to prove it is an irrational number. I have to prove it. I have to prove it's irrational number. I assume to be rational number. Contradiction method, remember. I will see what is happening. I don't need this part also. So let me just check. X square is equal to square and square root cancel. Here we are left with 3 plus 2 square root of 15. Already I have done 2. These two are same square root and this also square root. Multiplication you can multiply inside. 3 5s are 15. Plus root 5 square, it is 5, and x square is equal to 3 plus 5 is 8. 8 plus 2 root 15. Okay, you cannot add with 3 plus 2. You can, because this is irrational. So what do we have now? X square is this. Means what? Means what? Now I will do one thing here. See, x square. Let me shift everything this side. Minus 8 equal to 2 root 15. You know, I hope you know transposition. 8 comes this side, becomes minus 8. Now x square minus 8 divided by 2 is equal to root over 15. This 2 comes down. These steps okay? Now let's see. If I'm going to write one step here, very important step. If x square is rational, if x is rational, let me say, if x is rational, implies what? It implies what? It implies x square is also rational. Check. I assume that x is rational. Okay. Now what is the conclusion? If x is rational, x square is also rational. Okay. Now x square is which side? This side, no? This side, no, x square. See, x square minus 8 by 2. Now x square is what? Rational. If x square is rational, means this whole thing will become rational or not? Just check. Check. X is rational. I already assumed that assumption. Let x be rational. If x is rational, x square is also rational. That is for sure. See, 2 by 3 is rational, no? Now square it up. 2 by 3 ka square. How much? 4 by 3 square is 9. 4 by 9 is also rational. So that's just an assumption. Why do I have to use x square? Because x square is here, no? That's why. If x is rational, x square is also rational. Now check. If x square is rational, means this side is rational. Because x square is here, rational subtracted with 8 divided by 2. You will get rational only, no? You will get rational. Which implies, now x square minus 8 by 2 is rational. Okay? But root 15 is not rational. Check. What am I writing here? Check here. I'm going to explain you again. X is rational, x square is rational, means this whole thing is rational. If this whole thing is rational, okay, so this also should be rational, no? Because this whole thing is equal to this. Check. Because something is equal to, see, left hand side is equal to right hand side. Check. If left hand side is rational, right hand side also should be rational, no? Correct or not? Now have a look. Now, what did I say? X square is rational, means this whole thing is rational. Now, x square is rational. But this is what? X square minus 8 by 2 is what? Rational. But if this is rational, this also should be rational, no? But what is happening here? But root 15 is not rational. So, which contradicts our assumption. I assume that x to be rational. Yes? But now, if x is rational, things are not working out. I assume no x is rational and x square is also rational, fine. But when I put it here in the last step, then if x square is rational, if x is rational, x square is rational, this everything should be rational. If this everything is rational, because this is equal to this also should be rational. But now we are contradicting it. Means we are having a false statement now. Whatever I assume it is not coming our answer. Now check here. By an assumption, if x is rational, okay, and x square is also rational. X square is also rational, means after that when I put here this is rational, this also we should get rational, but we are not getting it. So that means it's contradict. Whatever assumption contradicts. So what can I say now? This is rational, but this is not rational, because this is equal to this. Both should come rational. But here we are not getting. Okay. root 15 is not rational, which contradicts our assumption, therefore root over 3 plus root over 5 is irrational. See, contradiction means what? We have assumed to be rational, but things are not working at last. So that means what? We have contradict that we are assumed to be rational. So contradict means output will be irrational now. So this is how you can prove it, something to be irrational. Prove, they say prove it. So you have to prove this way or with long division method. But if they just say examine it, by just looking some of the things are very clear. Some of the things you have to simplify it. Okay, so what you can do, okay, this way you try one more sum. Prove that root 5 minus root 3 is irrational. Try this one by yourself. This is not a question in the textbook because we are done with the textbook questions. Whatever is to be done, we are done. Now I want you to do this one, and you have to prove that this is irrational. This is question number 1, and question number 2 is what? Prove that root 7 minus or plus root 13 is irrational. Well, let me just write here root 7 plus 5 is irrational. Okay, we are very clear because this is irrational added with rational, but the output is irrational. But my question is prove it. By contradiction method you can do. So that's all for today, all of you. Thank you very much. So see you next day with the next video. Until then, take care. Bye bye.